The goal of this lab is to synthesize 2 alkyl halides, 2-chloro-2-methylbutane, and 1-bromobutane via SN1 and SN2 respectively. The products will be isolated via simple distillation and analyzed using the silver nitrate and sodium iodide tests. Before starting the experiment, safety equipment such as lab attire, goggles, and gloves are mandatory and should be worn at all times. Since there are 2 experiments, we will first show the synthesis of 2-chloro-2-methylbutane via SN1. The first experiment is the synthesis of 2-chloro-2-methylbutane via SN1. To begin, T-amyl alcohol was measured and transferred into a separatory funnel, followed by concentrated HCl. The separatory funnel was then swirled and shaken for a few minutes and placed back to allow the layers to settle. Once the layer settled, the organic layer, which was the top layer, was kept in the separatory funnel. It was then washed with brine or saturated sodium chloride, and the separatory funnel was shaken with intermittent venting. The layers were then separated and the organic layer, the top layer, stayed in the funnel. It was then washed with sodium bicarbonate to neutralize any excess acid. Shaking this funnel must be done with extreme caution as it produces carbon dioxide gas. Be sure to vent frequently. The layers were then separated and the organic layer was on top. The organic layer was then washed with water to remove any residual sodium bicarbonate. The layers were then separated and the organic layer was still on top because it is less dense in water. The final wash was with brine. After shaking and venting the separatory funnel, the aqueous layer was discarded and the organic layer was transferred to a flask. The organic layer was then dried with sodium sulfate to remove residual water. A round bottom flask was then clamped to the ring stand and a boiling stone was added. The dried organic layer was then transferred to the round bottom flask using a pipette. The remaining simple distillation apparatus was assembled over the flask. At the receiving end, a pre-weighed flask was attached and put on ice. Before starting the distillation, make sure the flask is weighed so you are able to calculate the percent yield. The flask was then heated and the product was distilled over. The product was collected until the thermometer in the still head read about 80 degrees Celsius. Once this temperature was reached, the heat was removed from the distillation and the receiving flask was removed. It was then weighed so you could calculate the percent yield. The next experiment is a synthesis of 1-bromobutane via SN2. To begin, sodium bromide was added to a round bottom flask followed with some water. 1 butanol was then measured and added to the flask. The flask was swirled and then put on ice. Concentrated sulfuric acid was slowly and carefully measured and put into the flask and immediately put back on ice. Once the sulfuric acid had been added to the flask, it was clamped over a heating mantle and a boiling stone was added. Then a condenser was attached with the water in at the bottom opening and the top opening was connected to the drain. This is the reflux apparatus. Once assembled, raise the heating mantle to the flask and turn on the water and heat. The flask should begin boiling, but because the condenser on the top, no vapor should be escaping. The reaction will be reflux for 45 minutes. Once the 45-minute reflux is complete, remove the heat and let the flask cool. Don't turn off the water because you don't want your vapors to evaporate. Once cooled, the condenser is removed and the simple distillation apparatus is assembled. This was done by attaching the still head to the flask, the condenser on the side arm of the still head, and the vacuum adapter to the condenser. Make sure it is firmly attached and bonded with the blue Keck clips. On the receiving end of the simple distillation apparatus, attach a flask to collect the product. Put the receiving flask on ice and attach the thermometer adapter. Once assembled, the heating mantle was raised and the water was turned on with the heat. Everything should be collected until just about 115 degrees Celsius. Once 115 degrees Celsius was reached, the heat was turned off and the heating mantle was lowered. The flask was then removed from the apparatus. The flask was then emptied into the separatory funnel and it was washed with water. While shaking, remember to vent. Once the layers separated, the organic layer was added back to the separatory funnel. The organic layer is on bottom because 1-bromobutane is more dense than water, so it will sink to the bottom. Once the organic layer is added back into the separatory funnel, it is washed with sulfuric acid. Again, remember to vent. The layers were separated, and the organic layer, which is now on top because it's less dense than sulfuric acid, is transferred back to the separatory funnel. The bromobutane was then washed with 2 molar sodium hydroxide to remove any acid. The separatory funnel was shaken with intermittent venting. The layers were then separated, and the organic layer, which is now on the bottom again, is transferred back into the funnel. The washing with 2 molar sodium hydroxide is repeated again to remove any residual acid. The organic layer is then washed with water and the separatory funnel is shaken with intermittent venting. The bromobutane, which was the bottom layer, was then transferred to the separatory funnel and washed with sodium chloride. Washing with brine or sodium chloride removes any water from the organic layer. After shaking and venting, the layers were separated and the organic layer, the bottom layer, was transferred to a flask. The organic layer was then dried with sodium sulfate until no more clumps formed. The flask was then decanted into a pre-weighed flask without transferring any sodium sulfate via pipette. Make sure to weigh out this new flask so you are able to calculate the percent yield via the difference. The final part is a sodium iodide and silver nitrate test. The first test to be conducted is a silver nitrate test. Using a pipette, equal amounts of silver nitrate and ethanol was added to 3 test tubes. Three alkyl halides will be analyzed during these tests. The first is a tertiary alkyl halide, which is the SN1 product that was made, 2-chloro-2-methylbutane. The second is a secondary alkyl halide, which we will be using 2-chlorobutane. The sample is the primary alkyl halide, 1-bromobutane, which is the SN2 product. Using a pipette, small amounts of each sample were added to the test tubes. For this video, the test tubes are organized as primary, secondary, and tertiary from left to right. Observations were then recorded to see the rate of reactivity of each. Note if there is a correlation between the substitution of the alkyl halide and the mechanism of the silver nitrate test. The second test to be conducted is a sodium iodide test. Using a pipette, equal amounts of sodium iodide and acetone was added to 3 test tubes. The same 3 alkyl halides were tested. Small amounts of each were added to the test tubes using a pipette. Again, the test tubes were oriented primary, secondary, and tertiary from left to right. Observations were made to see the rate of reactivity of each. Note if there is a correlation between the substitution of the alkyl halides and the mechanism of each test.
That's a lot of product, Connor.
So let's do that again.